In example 2, a rock is dropped from a height of 64 feet. It's determined that its height in feet above the ground t seconds later, from 0 to t, is given by s of t equals negative 16 t squared plus 64. And that is a very common physics formula. When something's dropped, it has no initial velocity. So, we want to find the average velocity of this rock over the given time intervals, and then use the information to guess the instantaneous velocity at a time t equals 0.5. If you notice, the first interval is coming from the left, prior to t equals 0.5, and the other is looking at the 0.01 seconds past that. All right, so for our average velocity, okay, so velocity average equals s of t minus s of a divided by t minus a. Right, so that would mean our average velocity here is s of, in this case, our value is 0.5 for a. So this is of the form t comma a. So this would be s of 0.49 minus s of 0.5 using our function notation divided by 0.49 minus 0.5. Now evaluating the function at 0.49 and 0.5, and then I'm going to go ahead and subtract those. That would be 0.1584. And subtracting the denominator, that is negative 0.01. So our average velocity is negative 0.15, negative 15.84. Move the decimal 2 places. Now, finding the other side of that, it will be much the same. Find s of 0.5, 0.51 minus s of 0.5 divided by 0.51 minus 0.5. Again, subtracting these. 0.01 for the denominator and negative 0.1616 for our numerator, which means our velocity is negative 16.16. Now those are both in feet per second. Let's go ahead and add that. Now, to make a guess at our instantaneous velocity, based on those two, appears that it could be 16 feet per second. And applying the derivative, which we'll see in another chapter, we can see that it actually is going to approach that. So that would be a good guess